Okay, we're going to go ahead and attempt to do this particular question, and we're going to look at what it's asking for and try to deduce it. So here we're giving the diagram for exercise 5 and 14, and we're also provided the question initially of naming two pairs of each angle type. So the first question is corresponding angles. Now I have over here an example of all the angle properties, and it tells us the corresponding angles are equal, for example, A and E, as well as B and F, essentially also C and G and D and H. Now, another way to look at this is that corresponding angles are a little more definitive than just that as an example. So let's see if we can make something a little bit better and easier to understand. Another way to say this is corresponding angles are the same if we have a parallel line. 1 and 2 is our parallel line, and 3 is going to be our intersect, or the line that crosses those. So essentially these two are the parallel lines, and then from a diagram we can see that A and B are relatively the same position. This would be considered our corresponding angles. A and B are corresponding because we have a parallel line and an intersecting line that transfers over both. Similarly, what they were trying to show here is corresponding angles of A and E. So here you would have your parallel lines, and then the intersecting line here. These two angles would be relatively in the same position, so those would be considered corresponding, just as B and F. So if we look back at our diagram, one of the things we could say is that D and E lines are parallel, and let's say this is an intersecting line of C, so our corresponding angle would be 3 and 8. And the second one, because it asks for a pair of angles, D and E again is our parallel line. Let's say B is our intersecting line. Then the angles of 1 and 7 are in a relative position, so they would also be corresponding. So essentially what we're saying is angles 3 and 8 and angles 1 and 7 are your corresponding angles. Now moving on to number 6, it's asking for us alternate interior angles. Alright, so alternate interior angles adds up to 180 degrees, like your C and E. But it's asking for alternate interior angles. So basically what we're going to do is, let's see what that means. So for alternate interior angles, first thing you got to have is a couple of parallel lines, and then the line that intersects the two parallel lines, two or more, is called the transversal. And what we're looking at is the interior angles, which would be in this area, but it's looking for alternate interior. So let's say that these are two parallel lines. This is our transversal that's cutting into them. Interior angles, alternate would be 3 and 5. And if we had this identified as 1 and 2, all of these would be kind of considered the interior, but alternate interior would be 1 and 2. So it's the opposite side internally of the line that's bisecting the two parallel lines. So if we come over here and look at our major diagram, and we're looking for alternative interior, we could say that the D and E are our parallel lines. Looking at the interior angles, the alternate interior, C is our transversal, so 5 and 8 would be our alternate interior. Similarly, D and E are parallel lines. This time now B is our transversal cutting into. Alternate interior would be 4 and 7. So our angle 4 and 7 our alternate interior in angle 6 and 8, or rather 5 and 8 is our alternate interior angles. Okay, now on our last, number 7, it's asking for same side interior angles. So we touched base a little bit on interior angles, but this time it's asking for the same side of an interior angle. So as an example, what we're looking at is two parallel lines and then a transversal that's cut in two. Now the thing on the same side interior angles, they're also noted as they have to be 90 degrees on inside, but they're also known as co-interior angles. So basically what we're looking at is the angles are being 90 degrees within, because the same side interior angles needs to equal 180 degrees. That's one of the rules for the same side interior angles. So let's say as an example we have 1 and 2 parallel lines that are cut with our transversal. 1 and 2 would need to equal to 180 degrees to be considered a same side interior angle. Alright, so if we look at our diagram, let's try to identify those two specific ones. So what we could do again is have our D and E being our parallel lines, and now let's look at C as a transversal that's cutting in. On an interior angle that's the same side would be considered 5 and 6, and those two would add up to 180 degrees. Similarly, what you could do also is look at, it would be 2 and 3, no, that's the exterior, this is interior. Alright, so 5 and 6 are our interior lines and same side, being 180 degrees. That would be one example of it. So another example could be again the D and E parallel lines, transversal being B. If we're only looking at these three inside lines, would technically be 1 and 7. So that would be another example of inside or same side interior line angles. Alright, hope that helps.